Okay, how do I do letter B? Letter B says f divided by g prime of 8. Help me out. F prime of 8. Front page times g of 8. Minus g prime of 8. Times g of 8 divided by g of 8 quantity squared. Yep. So that's what we're trying to determine. So make sure you plug in the correct values. So we have f prime of 8 is negative 6 times g of 8 is negative 3. G prime of 8 is 1. F of 8 is dos, which is Spanish for 2. And then g of 8 is negative 3. And we have to square that. See, we get 18 minus 2, which is 16, over 9. It's a good AP question. Questions? Flip it over. Equation for a line tangent, x equals 1. You're going to get a few questions like this on the exam. The way in which that they are phrased are slightly different from time to time. We'll help you sort that out, but this is the way I phrased it on the test. Write an equation for a line tangent at x equals 1. What do you do? What two things do you need to write an equation for a line? Slope and a point. What's the point? 1, how'd you get 0? You plugged it in? Good, so I get 1 minus 3 minus 1. 1 minus 3 is negative 2, minus 1 is negative 3. If I plug in 1 here, I get 6 minus 3 plus 1 minus 5. So 6 minus 3 is 3. 3 plus 1 is 4. 4 minus 5 is negative 1. So we do not get 0. Okay. So negative 3 times negative 1 is 3. So the point is 1, 3. Great. So some people might be in this situation and they might multiply everything out. We want to multiply everything out, take the derivative. I say that there's an easier way. We find the slope by taking the derivative. Help me out. Two x minus 3 times 3x to the 4th (6x to the 5th) minus 3x squared plus x minus 5. We cannot simply take the derivative of both parts. We must use the product rule as they're being multiplied together. So the derivative of the front times the second piece plus x squared minus 3x minus 1 times, now what? 30x to the 4th. Good. So where did we get the, we had 2x minus 3 and we changed it back to what it was before? So this is the product rule, f prime g plus g prime f. Yes? Yes. Okay. So now we plug in 1 and you get 1, or you get 2 minus 3 is negative 1. If you remember from our work earlier, I believe this came out to be negative 3, didn't it? We plug in 1 here, and we came up with, wait a minute, it came out to be negative 1. Negative 1, excuse me. Negative 1. Negative 1. The work here came out to be negative 3. And we plug in 1 here, we get 30 minus 6 is 24. Plus 1 is 25. Negative 1 times negative 1. Plus negative 25, or 75, excuse me. So slope is negative 74. I plugged in 1 because it says the equation at 1. So here's what you can do on the AP exam. You do not have to write in slope-intercept form. You can simply write as y minus 3 is equal to negative 74 times x plus 1, or x minus 1. You do not have to write it in slope-intercept form. They'll accept that. Questions? Okay, let's find these derivatives.
So the actual answer.
Write an equation for a line. Find the derivative. What's the derivative? F prime of x. Tell me how. 3 secant squared of x. If you don't know the derivative tangent is secant squared on the AP exam, you're going to have a long day. F prime of x. Tell me how. Product rule. So 4 times cosine times cosine would be 4 cosine squared. So I'm going to treat 4 sine of x as f, and I'm going to treat cosine of x as g. So the derivative of 4 sine is 4 cosine times cosine is 4 cosine squared. And now the derivative of cosine is negative sine, so negative 4 sine squared of x. Don't be surprised if they factor out the 4 and write as cosine squared of x minus sine squared of x. And remember, cosine squared minus sine squared is? No, it's nothing. It's cosine squared plus sine squared. It is true that cosine squared minus sine squared is actually cosine of a double angle, but you won't see that expressed. How do I do letter C? Chain rule. Yeah, what's the derivative of the inside? Yep, so I have 6 minus 4x on the inside, and the outside I have u to the 10th. Derivative of the inside is negative 4. What's the derivative of the outside? Yeah, so you get f prime of x is negative 40 times 6 minus 4x to the 9th power. Sometimes you don't have to set up the boxes. So, just to be clear, yes.
Like if I wrote just the answer, I didn't have that.
So they follow your work for your free response meticulously, okay? So you need to communicate mathematically to them. Now, you know, this type of result, you know, you're going to see it in a multiple choice setting. But suppose that they said for question, let's say they had 2B. They said, what is, you know, free response? What's the derivative of that? You could probably just write the answer and they'll be fine. But it would be nice to write f prime or y prime. Okay. All right. This one, derivative of the inside. 5. What's the derivative of the outside? So secant of 5x, tangent of 5x. Yep, that's what we did. We did the chain rule. Yep, we did it in our head.
I can't do any of this in my head. Stop that.
Nope. Letter G. Letter G. Tell me how to get started here. Yeah, so you'd have 6 times 4x minus 1 to the negative 5th. Radon. No. Nope, not at all. Because remember, the derivative of secant of u is, if you take the derivative of that, you get secant of u, tangent of u. There is not a factoring out of a 5x. This is not secant times u or tangent times u. So no, nope, not allowed at all. 0 points. All right. So I'm just telling you, it's no longer me grading your work. It is the AP, and there's no thing called partial credit, okay? So, sorry. All right, what's the inside? What's the outside? All right, derivative of the inside. Derivative of the outside. Yeah, so as you multiply these together, you see negative 120 over 4x minus 1 raised to the 6th power. That is the derivative. What would you like to do for letter H? Yeah, quotient rule. And so the quotient rule says we take the derivative of the top, which is e to the x, times what? The bottom, which is e to the x minus 1, minus what? The derivative of the bottom, which is e to the x, times the top. Over what? Good. Does anybody see what's going to happen in the top? Yeah, you see the e to the x, e to the 2x and e to the 2x will cancel out. People see that?
Yeah.
But we'll be left with a negative e to the x.
Yep.
So I have negative e to the x over e to the x minus 1 quantity squared. No, they will not express the bottom multiplied out. No. And to be clear, this will again, if this question was asked, it would most likely sit in the multiple choice section. Okay. If you did multiply out on the free response, they're not looking for, as long as it results in a correct answer, they're not going to say, well, we want this simplified form or this simplified form. Okay. So you could leave, like, for example, suppose that there was an answer on the exam of 2 over the root of 3. And you've been told your whole life to not leave a radical in the denominator, correct? Now, they may not leave it with this in the multiple choice, but in the free response, you could totally leave it like that. Because that is the same as 2 roots of 3 over 3. They're not going to mark it wrong because you don't know the magical, oh, give him a round of applause. Yeah. All right. Way to go. We believe in you.
Well, half the stuff in the ACT I never saw.
Shh. Here we go. Letter I. Derivative e to the 5x. It's e to the 5x, right? Nope, it's 5e to the 5x. Chain rule, folks. Chain rule. Okay?
Wait, what happened? What did you just do here?
I took the derivative. I used the chain rule. Derivative of 5x is 5.
You just didn't write it in the box.
I'll write the boxes. E to the u, 5x. The derivative of 5x is 5. The derivative of e to the u is e to the u. I'll draw the box again. We have 8e to the u. We have the root of x. What's the derivative of 8e to the u? 8e to the u, derivative of root of x. Good. So when you multiply those together, what is your coefficient going to be? 4e to the root of x over the root of x. We have to put a plus c. That's when you do integrals. Hold on, she's standing there. Why did she do that? Just come on in. Like, what do you?
Don't need to interrupt your.
Come on. Uh-oh. Oh, she did it. Yay, you're so much better. She's boring. She doesn't do it. Yeah, well, I'm calling you out until you do it. Hey, don't even act like that. Okay. All right, here we go. So a couple of these questions, a lot of these have just been to help us remember, this is the AP question, okay? So this is the AP question you're going to get. The other ones are not. They're going to say, you already know how to do that. Let's see if you know how to do this. Somebody tell me where to start. Product rule first with the chain. Everybody see that? Here we go. F prime of x, focus. This is the question. This is the one you're going to get, not the others. What's the derivative of x? Times? Good. Easy so far? Plus x times, anybody see what it is without doing the boxes?
3 times
Are we doing product and
no, 30.
30 times
30.
Are we doing product and chain here?
Yeah. They will not write the answer like that. What will they do? How? Take out the 3x minus 1 to the 9th. When you take out the 3x minus 1 to the 9th, what's left here? 3x minus 1. What's left here? Everybody see it's 30x plus 30x. So therefore, you can see that you get 3x minus 1 to the 9th times 33x minus 1. That's the answer they'll give you. That's the derivative they'll ask you to do. ACT, AP, everything, they love to give you questions that require you to do more than one thing. Question. Right here, that's the addition. We good? All right, write equation for line. Here it comes again. What do I need in order to write equation for line? All right, I need slope and I need a point. What's the point? 0 what? What's the sign of 0? Can't use your calculator. It is 0, so I add 2, I get 2. Good. I know the y-intercept. They're making this problem easy on me. How do I determine slope? Derivative. What's the derivative? Sine of 4x. 4 cosine of 4x. Oh, sweet. So, if I plug in 0, what's the cosine of 0? 1. Remember, you're not going to get a calculator on that, right? When you plug in 0, the cosine of 0 is... Okay, pause, time, right here. You have to know this. 0 is right here. What's that coordinate? 1, 0. Is cosine the x value or the y value? So cosine is 1, y is 0. I don't remember anything. I reconstruct it. Every time I reconstruct it. I don't ever go just based off memory. I think of that every single time. Don't memorize anything. Reconstruct it, and then you'll know it every time. You plug in 0, you get 1 times 4 is... So my slope is 4. I have the y-intercept. It is 2. So therefore, the equation is y is equal to 4x plus 2. More derivatives. How do I do this one? Chain rule. What's the outside? Natural log of u. What's the inside? What is the derivative of 4x minus x squared? What is the derivative natural log of u? 1 over u. So what goes in the top? What goes in the bottom? Good. Excellent. You're done. Letter B. Where do you start? Nope. Nope. Come on. Yep, thank you. Okay. It's going to make life a lot easier. You're going to make a mistake otherwise. So therefore, we have 6 natural log of x minus 4. Now the problem is easy peasy. Yeah, now do your chain rule. What's the derivative of x minus 4? 1. What's the derivative of 6 natural log of u? 6 over u. So it's easy to see you get f prime of x is 6 over x minus 4. We made that a lot easier than it would have been otherwise, right? Letter C, what do you want to do first? Product. Excellent. So you get 2x times natural log of x. Then what? Plus x squared times. Good. So I have 2x natural log of x plus x. They won't write the answer like that in some situations. If they didn't write it like that, how would they write it? X times the quantity, 2 natural log of x plus 1. So either way, be ready to do that. You guys are smart. All right, enough of a lesson. I think you got the idea. Let's move along. Arctan of 3x. Not a lot of questions like this you get in the exam. Every once in a while, see inverse of an arc function like that. Let's just do it because we've talked about it. So what do? Good. Chain rule. What's the inside? 3x. What's the outside? Arctan, which is same as tangent inverse. What's the derivative of 3x? 3. What's the derivative of arctan? 1 plus u squared. Good. So what goes on the top? Good. 3 goes on the top. What goes on the bottom? Good. 1 plus 9x squared. Good. So I would see that maybe sitting within a free response question where they're trying to figure out, okay, we've only got 7 points on this free response. We got to come up with 2 more. We'll ask them a derivative that's just, kind of off somewhere, okay? How about this one? E to the x to the inside. What's the outside? Secant inverse of u. What's the derivative of e to the x? It's a beautiful thing. And derivative of 4 arc secant. Good. U root of u squared minus 1. This is the one that has the u out front. And then instead of 1 minus u squared, it's u squared minus 1. Hey, folks, if you don't remember that, that's not a big deal. You might miss a problem on the test. But if you don't remember the derivative of cosine is negative sine, it's time to panic, okay? So as we multiply, we got 4e to the x over what goes in the denominator? E to the x times e to the 2x then minus 1. And what happens? Yeah, that's pretty cool, huh? I'm sensing some sarcasm. All right, and arc sine goes the same way. Let's not do the whole problem. Just tell me what is the derivative of arc sine?
1 over.
Good. Yep. That's the derivative of arc sine. It's the same process. We've spent enough time on that. Let's move along. Great. We want to find y prime. You'll see this listed not as y prime, but find dy over dx. That means the first derivative with respect to y. If you see this, if you see that, that means second derivative. Okay. We don't use the Leibniz notation. We tend to use the Newton notation. But this means first derivative. That means second derivative. Do be ready to see dy over dx. Everybody understand that means derivative? If it's a 2, it means second derivative. What if it says 3? Third derivative, so on and so forth, okay? So you can see how that notation was useful. So we want to find y prime. What's different about this compared to the other problems we've done? Yeah, exactly. You got y's in multiple places. So what's the derivative of 5x squared? 10x plus 8y prime. Or some people write as 8y dy over dx. So we use the y prime notation, and that suffices on their test. Equals what? 8 minus 3y prime. Now what do? You were really good at this. Yeah, get everything that has y prime on one side, right? So 8y prime is plus 3y prime is equal to 8 minus 10x. Factor out the y prime. 8y plus 3. 8 minus 10x. So y prime is 8 minus 10x over 8y plus 3. And you recall that, right? Let's not see B all the way through. We're trying to save on time here. What's different about letter B? Okay, so product rule then. Yeah, so this is F and this is G. So let's do the first part. Derivative of xy would be y plus x y prime. Are we okay with that? Minus, so I'm going to put the minus there, and I'm going to choose to distribute it through because I've made enough mistakes. I'm tired of making those mistakes. I know the derivative of x is 1 on the end, but now let's call 3x f, and we'll call y squared g. So product rule again. 3y squared plus so I'm going to have 3x times 2y prime. So 6xy prime. So I had the product rule twice, right? Do be ready to use the product rule for implicit differentiation. I've seen it many times. And after that point, you know what to do, right? Gather your y prime terms, factor, and solve. Flip it over. Limits. Great. Determine the following limits. We've talked about limits before. The first one, I don't really want to factor it. If you plug in 1, what do you get? You get 0 over 0. Do you remember what you can do if you get 0 over 0? Yeah, L'Hopital's rule says take the derivative of the top, derivative of the bottom. So we got the limit as x goes to 1 of great. You plug in 1, what do you get? 8/9. That was cool. And do you understand why they would like that question? You have to have knowledge of limits and derivatives. Get the idea? Great. Next one, plug in infinity, you get infinity over infinity. If you get infinity over infinity, then you could also use L'Hopital's rule. What's the derivative of the top? 3e to the 3x over. If you plug in infinity, what are you going to get? You're still going to get infinity over infinity, aren't you? Do it again. You get the limit as x goes to infinity of 9e to the 3x over those. You get infinity over 2, which is infinity. Limit as x goes to 0 of tangent over sine. Plug in 0 for tangent. What do you get? 0. Plug in 0 for sine, you get? If I get 0 over 0, I could go ahead and use L'Hopital's rule. I have the limit as x goes to 0. You all remember what the derivative of tangent is. Secant squared of x over cosine of x. Uh-oh, I don't know how to define secant. No worries. Let's do cosine first. What's the cosine of 0? It is 1. So when you do secant, secant is the reciprocal of cosine. So what's the cosine of 0? 1. Take the reciprocal. 1 squared is 1. So you get 1. We plug in 1. Oh no, now I have to know what the natural log of 1 is. Great. I don't get a calculator. I have to know that. And the bottom you have 0. So I will use L'Hopital's rule. Derivative of the top over x divided by -1. Can I plug in 1 now? What do you get? -1. Letter E, sine of 0 is 0 over 0, L'Hopital's rule. What's the derivative of sine of 2x? Good, you use the chain rule, nice and quick, 2 cosine of 2x. Notice how we don't like to use the boxes when we're doing something this straightforward. Okay. I plug in the 0 for the cosine of 2x, and you get cosine of 0 is 1 times 2, so I get 2/3. And you learned how to use the rules as x goes to infinity. Can anybody just look at this and tell me what the answer will be? It is 3/2. You can go ahead, if they have the same degree on top and bottom, look at the coefficients for the front and divide them. Yep. And to be clear, Abby, if you were in this situation and you plugged infinity, notice you get infinity over infinity, and you use L'Hopital's rule, what's the derivative of 3x minus 4? And what's the derivative of 4 plus 2x? So even if you don't see it, L'Hopital's rule works right away. No, because 2 times 0 is 0, and the cosine of 0 is 1 times 2. Yes, that is your order of operation. Okay, use a graph of f prime is given to the right. Use a graph to answer the following. This is f prime. Who can tell me where is f, the original function? Where is original f increasing? Why? Because that's where f prime is positive. You will get at least 4 questions about this on the AP exam. This is probably the most critical content. Okay? Got to be able to read and interpret the graphs, folks. So, when is f decreasing? Okay. I'm going to say hi to Kiara real quick. My daughter, she's going to be watching these videos because she's... Hi, Kiara. Forgot I'm making this video for you today. So she's got to watch these. She got to take the exam. They have block scheduling. She finished calculus back in December, so she doesn't have. There's no review. Yeah, they have a block scheduling, so you can take your class at a different time. All right. F have a local minimum. Why? Because you're looking for a local min where f prime changes from negative to positive. So when f has a local maximum is when f prime changes from, yep, where does f prime change from positive to negative? 10. I don't know how to get you guys to remember it. I promise you're going to get those questions. You have to remember this. You have to remember maximum is when it goes from positive to negative, negative to positive. If you can visualize that in your brain.
When it's minimum, then you have the minus before the plus. When it's factoring into plus.
Yep. However you do it. Uh-oh, when is f concave up? Concave up. How do I determine concavity? Second derivative. You tell me, okay? Second derivative. I got my first derivative, so I'm going to mark second derivative. Second derivative is going to be like this. Right? That's going to be the second derivative. Tell me something about the second derivative right here. It's positive. So am I concave up or concave down? Concave up. Concave up is when the second derivative is positive. So therefore I'm concave up from where to where? Negative infinity to 5. Good. Concave up, negative infinity to 5. Well, if you look, it's going to change right here, right? Right here at 5 is when it changes from positive to then it's going to slope to negative. So we're going to be concave down from 5 to infinity. When does inflection occur? When f double prime changes sign, right? When it changes from positive to negative or negative to positive. So in Morgan's question regarding how do we know 5, that's when it changes positive to negative. So x equals 5 is our point of inflection. Excellent. Because you don't know the value of this is not the original graph. Okay? Let's see if I can answer this. Okay, here you go. You have an assignment, okay? Look at your AP stuff right here, okay? I want you to come back on Thursday and try the AP problems up until the section where it says area. See this part that says area right here? Just try them. 2 minutes per problem.
Okay.
Yep.
Here's the first night.
Yep. Try the AP problems. I want to start on Thursday going over those exact problems, seeing where you got them right or wrong. This is what it's going to feel like to show up and take the test, okay? So try those problems. Take it seriously. Be ready to go. I ain't going to be disappointed if you get 1 out of 9 correct. I'm going to be disappointed if you come back and you didn't try any of them. Okay?